this is what we just discovered, boys and girls in the viewing audience, that a tangent line is always perpendicular to the radius. That's conjecture C59. Okay? Now I'm going to pause. Maybe, if I can, if it'll let me move this circle. It won't let me change the size of that circle, which is weird. But what I can do, I'm going to draw in another radius. Okay? So I'm going to draw in another radius, any radius I want, right here. All right? And then I'm going to draw in another tangent by constructing a perpendicular. I would have you guys do this, but like I said, we have a limited amount of time. May I help you?
Yeah. Those coloring sheets I gave you before break, did you have them? Or do you use them all?
I don't know.
Are they in your room?
You could look. So what I was going to do here, am I recording now? Yeah, I'm recording. I'm going to make another perpendicular line from here to here, okay? And you notice those two things intersect. See that? Okay? I'm going to put a point at this point of intersection, okay? Then, as clever as I am going to hide these two lines. This is good review for show hide object. And I'm going to hide this. And I'm going to hide this. Remember, when I hide something, I have to click on this to make them disappear. And then I'm going to draw segments over the top. From here to here. And then from here to here. Got it? And then I am going to, no, I'm not going to do that. Edit, undo. I'm going to see if you can tell me something about this and this. I'm going to drag, stop. I don't want the point tool anymore. Edit, undo. Okay? I want this. I just want to move things around. Can I move that point? I can't really move that point. Can I move this circle? I can move this circle. I can't make this circle. I can move those. Okay? Who can make a conjecture about these two segments right here? What do you think? What appears to be true about this segment here and this segment here? This segment and this segment. Those two tangent segments. Well, I'm going to show you. Distance, length. I'm going to measure this. I'm going to measure this. Hey, they're both 6.81. Okay? I'm going to drag this now and see what happens. Hey, they're both 16.3. I'm going to drag this one. Hey, they're both 8.49. Who can fill in C50 conjecture C54 for me? Tangent segments conjecture. Tangent segments to a circle from a point outside the circle are congruent. Okay? See that? And so what I just did, I demonstrated that on GeoGebra. Normally I'd have you discover that, but I'm in a rush, so I'm not going to have you discover that. Okay. Say I were to, where'd my Sketchpad stuff, or my, who can tell me why this is true? Anyone think why that's true? I'll show you why it's true. What if I were to draw in a line right in here? And then I were to make a mark right here. Oh, no, what's got to be true about all the radii of a circle? What's good? This radius has to be congruent to this radius, right? Okay. What's got to be true about these two 90-degree angles? What's true about all 90-degree angles? They are those angles equal?
Yeah.
If there's okay. What else is equal in these two triangles? Did you guys forget everything? What? The same segment. Okay. So these this segment's congruent to this. This segment is congruent to itself. This angle is congruent to that angle. Are these triangles congruent?
Yes.
Why? What would this be? Which congruence proof would it let me, which triangle congruence would let me say that this triangle is congruent to that triangle? Huh? Side-side angle. Is side-side angle a way to prove triangles are congruent? No. But if there's a right angle, do you guys remember there's that hypotenuse leg? Remember we did that little worksheet? It's not in the book. But those two triangles are congruent because of the hypotenuse and leg of two triangles are congruent. Here's the hypotenuse. Here's a leg. It's a right triangle. Therefore, those two triangles are congruent. Therefore, these two pieces have to be congruent. Why? CBCTC. Okay? So that's why that, I basically just proved why that conjecture was true. Tangent segments conjecture. Tangent segments to a circle from a point outside the circle are congruent. So you could draw a picture to remind, that's why I drew little circles with all those, to help you think about what that means. Okay? So now, just a couple quick examples that I might have for you. So say I were to have a picture. I'm going to use my Mobi board. Where is my Mobi board? Did you guys see my Mobi board?
It's right here.
Oh! Why are you stealing my Mobi board? All right. So anyway, I'm going to draw a picture. Where's my piece of paper? Okay? So I'm going to draw a circle. Circle. Does the circle thing still work? Where is it? Hello? Circle? Is it going to make a circle? No, that doesn't look like a circle. Let's make a circle. There's a circle. Okay? So I have a picture that looks like this. And I have two segments drawn from points of tangency. Okay, say these are tangent segments, meaning they only intersect the circle over here and in one place. And then I were to draw this in here, and I would draw this in here. Okay? And then I tell you that this angle is, let's just say that this angle is over here 50 degrees. And I say, find the measure of angle X. Who can tell me how to find the measure of angle X? David?
You split that into two triangles.
You could do that, yeah.
Yeah, and then so you would, if you split it into two triangles, it'd be 25 degrees on both sides. And then since the top and bottom ones, they're 90 degrees,
Right.
you just subtract that.
Very good. So you could split it. You don't have to split it. You know that this is 90, right? You know that this is 90 because those are tangents. How much does that have to add up to?
360.
360. So this and this add up to what? 180. So this and this must also add up to 180. So what's this angle right here? 130 degrees. Do you guys understand why that works, right? Because these both have to be 90. As David said, you could have split it in half like that, but you don't have to, you know. Who can tell me what the measure of this arc from here to here is? What's the measure of that funky looking arc from here to here? How far is it from there to there? How many degrees is this arc? You guys remember that this angle and this arc have the same measure, right? So this, what's the measure of this arc? This arc, it has a measure of 130 degrees. So if I call this like arc, let's call it arc A, B, C, and I say the measure of arc A, B, C, what is it? How many degrees in a circle? How many degrees in a circle? 360. So you would take 360, subtract what? 130, and you get that arc ABC is, what's that? 180. 180.
Minus 130.
Minus 130. Oh, sorry. So that's going to be 230 degrees, right? Get it? Okay. One other type of thing that you may see is What if I were to give you this one's a little, you have to think a little bit more, okay? So say I were to give you something that looked a little different picture, where I do this. I'm going to draw this to here, kind of like the last one. I'm going to tell you that these are tangent segments, but I'm going to connect them right here. And all I'm going to tell you is that this angle here is 70 degrees. Okay, I'll call this A, B, C, and I'll call this X. And I say find the measure of A, X, C. That's trick. You're going to have one like this in your home. So, anyone have any ideas on this one? This one's kind of tricky. You got to draw in some extra lines. In the interest of time, I'm going to draw in the extra lines for you. Okay? Here we go. Make some dotted lines. Make this over here. What if I... Aha! Why would I do that? If this is 70, what does this... If these are tangents, what's got to be true about A, B, and B, C? These two things have to be congruent, right? So if this is 70, what does this angle over here have to be? This has to be 70. If this is 70 and this is 70, what's angle B?
40.
That's got to be 40, okay? You know this is 40. Based on what we learned in the last problem, what does this central angle right here have to be? We'll call it AMC. What's the measure of angle AMC? It's got to be supplementary to that, right? So this has got to be 140, right? Which means this arc over here is 140, right? Which means this arc over here would have to be 140 subtracted from 360, right? Which would be what? 220. That's tricky, yeah? Because like these, you'll go, wait, I thought these are supposed to be 90, but these are only 90 if they're connected to a radius, right? So you kind of got to be innovative and draw in some extra lines in them, okay? So that's kind of tricky. Just a couple more vocabulary words, and then I'm going to show you how to draw a yin-yang, okay? Let's see. So if you have two circles that are connected at like this, those circles are said to be, and they connect at one point, those are called internally tangent. Internally tangent circles. Tangents. And if you have two circles that connect like this, how am I going to do this? Make it touch at another point. Like that. Those are called externally tangent. Okay? And I'm going to show you how to make a yin-yang. You want to know how to make a yin-yang? You know what a yin-yang is? One of those things that mean peace and harmony and all that good kind of stuff. Here's how you make a yin-yang, and I'm going to say if you make a really nice one to turn in, I'll give you 5 extra credit points right off the bat. So a lot of you will have 150 points on that. You have to do one for your homework, but if you do a really nice one and you turn in on a separate sheet of paper, I'll give you 5 extra credit points. Okay? This is the way to make a yin-yang. You draw a circle using your compass and your protractor. Okay? You draw a circle, and then you locate the midpoint of a diameter. So I'm just going to say, here's the midpoint of that diameter, and I'm going to go like that. So that if I did this right, which I did, how come it looks like an egg? I don't know. Okay. But you do something like this. Oh, this is bad. It's hard to do without my compass. Let's see if I could drag that circle. Thank you. There. Okay. And then what you do is you make this, you erase part of your line. Okay, so you erase this part. Let's see if I can make it thicker. Thicker. You erase half of it over here. And then you erase half of it over on this side. See? If I did it right and everything was tangent to each other, then I get that yin-yang thing. See? And then if you want to make it fancier, you can like make another circle over here and there. And then you could color and make it look beautiful. Okay? And then you'll have peace and harmony in your life. Isn't that what that means? You got the good with the bad. And that's about it. So that's how you make that using your construction tool. Your homework is on Schoology. Do you want me to write that? Or you can figure that out. It's, where is it? Where is it? Schoology, I don't know. You can figure it out. Textbook, discovering GIM, you can figure out what your homework is, which is on Schoology.